All right. So we're going to work on logarithms today. Lots of algebra in this section today. And these properties right here you need to know. You can write them down for today, or if you received a packet in the mail, they actually would be coming up before the last lesson, because I went ahead and put the study guide in there just so you would have the list of properties. And so we'll go ahead and start. And the first questions have us convert from logarithm to exponential form. So back and forth. So we're not really using the properties yet. We're just going to go back and forth. And I'm going to switch and go down. Get a new screen for these. So this one is in exponential form, and we're going to convert to log form. And remember, these functions, exponential and logs, are inverse functions of each other. So you want to keep that in mind as you go. And I do these conversions just with a little spiral. Your base in both is going to be the same. That's the key. So we're going to start with the base, and you go a spiral around the equals, so that way it doesn't matter about your direction. And so this is going to be log base 11, because that was your base, of x equals 3. And you're set. I don't know if you have to type the parentheses or not. Let's try one, typing it in. So if I do log, if it had more than one thing in it, I would say yes, you had to. We want to go down with the subscript 11. And we'll see if I get away. It put the parentheses automatically for me because it knew I needed them. Okay. And it might even close them. You do need to put the equals here because you're writing an equation. All right. So that is how you enter. And these should move pretty fast for you. Some of them you'll have to pause and think about them. All right. So next I went to number 2. And I would rewrite, we'll write the problem first, but I would rewrite that as an exponent instead of a root. And remember, it's to a fractional power, and the 4 will be the denominator. So this is 625 to the 1/4 equals 5. That's just switching from radical to rational exponent. Now we want to switch it to log notation. And so we're going to do our spiral where you're going to start at the base and go this way. And so it will be log base 625 of 5. And they'll put the parentheses equals 1/4. And you guys stop me if you have a question as we go. All right, this one they have just switched the sides. So don't let that throw you. We have 7 equals 10 to the y. And we're just switching to log form. You're still going to start at your base and you're going around the equals. So you're going to go this way. And so we're going to do log base 10 of 7 equals y. Now, common log, the one that just says log, is always base 10. So I could put this and it should be right, but it should also be correct just to write log of 7 equals y. Either one. It should take either one. next I went to problem 5. And we have e to the 7th equals x. And we're going to switch the form. So you start at the base, right? And when you work with the base e, you're going to switch notation to natural log. And I usually use a cursive L there, just so it won't be confused with a 1. So natural log, and natural log is always base e. I mean, you can write it, but you won't see it written that way, of x equals 7. So ln of x equals 7. And I should put the parentheses, but it will help you if you don't. All right, next I went to 7. So these are just, it's a lot of problems over and over to make sure that you can do these skills, right, in different forms. So 7, I have the log base 32 of 2 equals 1/5, and they want me to switch to exponential form. You're still going to start at the base, and you're going to make a spiral around the equals. Right, so now exponential form will be 32 to the 1/5 equals 2. Or you could also write it with a radical. Either one should be accepted. This would be the 5th root of 32 equals 2. Let's see what they put. You could do either one. Right. I did pick 8 for you just to get used to the natural log notation a little bit. So 10 equals ln of x. We're still just switching forms from log to exponential or exponential to log. And so remember, on natural log, your base is e. And to switch form, you're going to start there. E to the 10th equals x. Spiral around your equals. I did pick 9 just to remind you, if a number is in the denominator, you get that with a negative exponent. So if negative 3 equals log base 6 of 1/216. All right, and we are just switching forms. So we're going to do around the equals. So start at your base. 6 to the negative 3 equals 1/216. Sorry, I shouldn't put my equals in there. So my new form is 6 to the negative 3 equals 1/216. Right, next I went to 11. And this is using one of the other properties. So, or one of the properties. We have just been switching forms to this point. And so now one of the properties, anytime you take a log of 1, the answer is 0, right? And they want us to just switch this still to exponential form, but this is one of our properties. So log of 1 is 0. So that's when you're going to memorize. But they want us to go to exponential form. So remember, your base on this is 10 on the common log. And so to switch form, it's 10 to the 0 equals 1. And you see you get a true statement with that. Right. Then I went down a little bit to number 14. And we're going to use a different property to help us get an exact value, right? You don't want, and this doesn't go in your calculator because your calculator works base 10. Your log button on your calculator is base 10. So with a different base here, you want to do something else. And the algebra here is actually easy. So our property for this one is going to be and I put this at the beginning of the lesson today, but when you take the log base b of b to some power, the answer is the exponent. So what you're going to try to do is make this base and this base the same, and then your answer will be x. So that's where you're going to work. So on 14, we're working log base 12. And this base we can't really change, so we have to work on changing the other one. So we would like to write this 144 as 12 to some power. And it is 12 squared. So we'll rewrite it. So log base 12 of 12 squared. And now we can use that property. All right. Once the bases are the same, the answer is going to be the exponent. So this will be 2. Here's another one just so we're comfortable with it. And so this says we have log base 4 of 256. They would like us to give an exact answer for that. And so we're going to try to rewrite 256 as 4 to some power. So you would just play with it on your calculator. And so, let's see, 4 to the third is 64, I think. So let's try 4 to the fourth is 256. So we're going to rewrite the 256 as 4 to the fourth. And once these bases are the same, the answer is your exponent. So the work is getting them the same. Right, let's do this one. Just to remind you how to get it to the denominator. So we have the log base 11 of 1 over 121. So we want to figure out somehow to write 1 over 121 as 11 to a power. Well, to make it go to the denominator, it's going to be a negative exponent. 11 squared is 121. So we can rewrite this as log base 11 of 11 to the negative 2, because that would move it to the denominator, 1 over 11, and then it would square it. Right. Once you get these bases the same, answer is the exponent. So a negative exponent moves it to the denominator. Right, then I went down to number 20. So we have the log base 4 of 1 over 9. All right, so we want to write this expression in terms of 4 to a power, right? And this denominator is 4 to the 1/9. That's how you get a radical off. But to make it be down here, it will be 4 to the negative 1/9. So this is equal to log base 4 of 4 to the negative 1/9. So the negative pushes it to the denominator. This puts the root on there. Right? Your bases are the same now. The answer is negative 1/9. It looks a little scary when you look at it, but just kind of take it apart. Right, and I had to think about this one a little bit. All right, so we have the log of 1/8 of 1 over 64. Okay, and so we need to write this as 1/8 to some power. So 1/8 would actually already have this in the denominator. So if we make this 64 8 squared, we actually would be there, even though it looks a little hard. So if we try log base 1/8 of 1 over 8 squared, because that would be 1 over 64. So it's good. These are the same. Answer is 2. I picked one more of those. 23. So the log base 1/7 of 343. Right? And so 343, we want to see first 7 to some power. I believe 7 to the third is 343. So you just have your calculator around and you check. So 7 to the third is 343. But I want to have 1/7 to something. And now this is not in a denominator. So, but if I want it from the base of 1/7, if I do (1/7) to the negative 3, right? That is going to make it flip over, which would give me what I have, which is just what I want, right? I needed to write it as 1/7, but I want it to match back to 343. So my base is now the same, and it would. This would give you 1 to the negative 3, 7 to the negative 3. They would switch places, and it would give you 343. Base is the same. Answer is negative 3. Good. All right. 24. This one's a little tricky. The log base 5/3 of 81 over 625. Okay. And we would like to write that as 5/3 to some power. When you try to play with it, you realize that 5 to some power, I'm going to end up with the 625, not the 81. I can't do 5 to some power and get 81. I can do 3 to some power and get 81. So, to make it flip, I'll use a negative exponent. So we'll do log 5/3, right? And this, we'll start with 5/3 here because that's what we want. And we want to make this work back. Okay? And so 5, we know we want it to flip. So it's going to be negative. And you can get your calculator. And so if we do, I believe it is 5 to the 4th. So if we try 5 to the 4th, 625, And so the 3 would also have to be to the 4th. 3 to the 4th, 81. Yes, it is. So if we do this to the negative 4th, the negative 4 would go to each one. They're both going to be negative, so it's going to switch it, flip it over, and that would make it 81 over 625. Okay. Goal was to get these two bases the same. Then the answer by the property is the exponent. Good. This one, it seems like you're having to think backwards a little bit because your base is bigger than what you're taking the log of. All right, so you're going to have to do some kind of root. And you can think of your relationship here. The square root of 9 is 3. So, and our goal is to rewrite this as 9 to a power. So if we write it as log base 9 of 9 to the 1/2, that would be square root of 9, which is equal to 3. Then we have this, and our answer is 1/2. Right, and this one is actually just a property. Log base 11 of 11 is going to be 1. We don't have an exponent on there. These are already the same. This is 1 with a property. Right, and this one looks hard, 28 looks hard, but it's going to be the same thing. These are the same. It's 1. The answer is 1. So they're trying to see if they can scare you. Next, they're pulling up another property, and this one will fit here. It looks like maybe I'm pushing it, but not really. The log of 1 with any base, the answer is 0. Okay. Doesn't matter what you put here. Here for the base, log of 1 is going to be 0. So that's a property that you want to know. 30, they're trying to make it, trying to make it look like it's a hard problem. It is just that exact property because you are taking the log of 1. You don't care what the space is down here. The answer is 0. No work. All right. This one, it uses the property we were using a while ago. It's just already set up for you. So the log base 8 of 8 to the 12, they put the 12 inside, but it doesn't matter if it's inside or outside. These are the same. The answer is 12. No work. So you see how fast these are. So don't panic when you see that there's 42 questions in there in the homework because they really are this fast. All right, so 33. This one really is just to remind you what the base on the common log is. So you have log base 10. They want you to evaluate it exactly. Anytime if you feel a little stuck, write the base on there, and then you will see it as your property. So it is log base 10 of 10. This is 1. Those are just alike. And 34 is just the other property. You're taking the log of 1. The answer is 0. It does not matter what the base is. Answer is 0. Right, 35. So this one is log of the 6th root of 10. And they want us to give an exact value. Write your base on there, right? We know it's a base 10, write it on there. And then just rewrite this as an exponent. So it's 10 to the 1/6. Whoops. Said 10, was writing 10, was thinking log. All right, log base 10 of 10 to the 1/6. There's your form. These are the same. Answer is the exponent. This one I had to play with a little bit. I knew what the answer should go to, and you can think of scientific notation, and it will help you a little bit here. So the log of 0.0001. Okay, so first of all, I put the 10 on here, and this is 10 to a negative power. That's how the decimal will move this way. And if you think of your scientific notation, this piece is 1 times 10 to the negative 4th, because you're 1, 2, 3, 4. So that is 1 times 10 to the negative 4, and 1 times anything gives you back the same thing. So this expression, we can write it as 10 to the negative 4. So log base 10 of 10 to the negative 4, and then we can get the answer because we're in our proper form. Right, 36. Then I went to 39. Right, these are using the natural log, and remember, natural log is base E, and you can write the E on there to help you. I'll do it first without. So they're putting so much notation here. They're trying to scare you. All right, and we just want to give an exact answer for it. So I am going to rewrite it with my E here, because that's the base. And I want to write this as E to some power. And you're just going to change to a rational exponent. So log in natural log base E of E. And remember, the index is the denominator. So this is the 8/5. So that is equivalent to this radical. And now our bases are the same. Answer is 8/5. All right, this one just has your E in the denominator. And remember, it is a negative exponent that put it down there. So when I rewrite it, so the natural log, I'm going to put my E on there to make it match. And to get this down here, it's E to the negative 6. Makes it that fraction. So your bases are the same. Answer is -6. Good. And this is a property, but if you get stuck, put the base on there. Oh, this is equal to 1. Because sometimes you do, and it helps to write the base on there. I told you wrong. It has 43 questions. Okay. All right, so 42. And so we have the ln of E squared, and we want to evaluate that. This is already in the proper form because our base here is E, and so the answer is 2. So you want to work a bunch of these just so that you're able to use those properties quickly. All right, I'm going to switch to the other section, so it'll take me just a minute. And I'm going to do the algebra questions first, domain. So you have two sections this time to do. This one has 12. The first part of it is graphing, which I'm going to try. I should have time to fit one graphing one in. But the end of it is algebra. So we're going to question 11. Actually 10. 10 and 11. These are about domain. And this is 5.2b. All right, and we want to determine the domain of log base 4 of x squared minus 64. So the question is domain, and your rule is that whatever you're taking the log of, it doesn't matter about your base, this has to be greater than 0. So x squared minus 64 must be greater than 0. Can't equal 0, must be greater than 0. All right, so you might remember from our last chapter, this was the polynomial inequalities, or quadratic inequalities is a polynomial. So we did this by finding the boundary points. So we did this as if it were an equals. We could factor, and this gives us -8 and 8. So we did a little number line in order, and you pick test points in each region. So we'll pick a -9, a 0, and a 9. You could pick different ones if you want. All right, and then I'm just going to test each one because this is always going to be with your function on the left, and over here it will be 0. So we can test and just get the signs. We don't have to actually get the number. And so my next one is x minus 8, and then the combo of those. So if I plug in -9 plus 8 gives me negative. -9 minus 8 is -17, and two negatives multiplied gives me a positive. Right? 0 going in. 0 plus 8 gives me a positive. 0 minus 8 gives me a negative, and multiplying a positive and a negative gives me negative. Plug in a 9. 9 plus 8 is 17. That's a positive. 9 minus 8 is 1. That's a positive. Multiplying two positives gives you a positive. Right, and we wanted greater than 0. So we want these two sections. You have to use parentheses because there is no equals underneath. So our answer in interval notation will be -infinity to -8 union 8 to infinity. All right, and one more of those. Well, it's actually like 3 of those, but that's good. So g of x is the natural log of 3x plus 9. And they're asking about domain, and then they want us to give the vertical asymptote. And it will be based on your domain. So domain is the question. and then we'll do vertical asymptote. All right, so all you care about is this piece. This is called the argument. This part has to be greater than 0. And then you solve. Now, this one is a linear inequality, and so it is isolate the variable. So you're going to take your 9 to the other side. So we have 3x is greater than negative 9. Divide by 3. We're dividing by a positive, so no flipping. X is greater than negative 3. So interval notation will be negative 3 to infinity. And your vertical asymptote will be with this 3. So it will be x equals negative 3. Remember, you're making a line there. That's as low as it can go, and it can't touch. That's an asymptote. All right. And so you want to write this as an equation. So it has a vertical asymptote at the vertical line, x equals negative 3. Right, and then I'm going to move this down so I can fit these others on. They're all part of the same question. So they are all domained, just a little bit different formats. So 11 part 2. So f of x equals log of 8 minus 2x. And we want domain and vertical asymptote. All right, so this is the piece we care about. We don't care about the base. Right? So 8 minus 2x must be greater than 0. And so we want to isolate the x, subtract your 8. So we have negative 2x is greater than negative 8. You are going to have to divide by a negative here, and that will make your inequality symbol flip over. So we have x is less than a positive 4. So this is going to come from negative infinity to 4. Your vertical asymptote will be 4. You're coming up to that. That's as far as we can go. It will be x equals 4. So it's an equation of a vertical line. So our domain first and our vertical asymptote. All right, we have one more of these. And this is h of x equals log of 1/9, base 1/9 of x squared minus 3x. Still a domain question. So we don't care about this base, that it's a fraction. We only care about this piece. It has to be greater than 0. So x squared minus 3x greater than 0. This is one of your polynomial inequalities. And so we had to get our boundary points. You can factor out an x here. So you're setting it equal to 0 and solving. We can take out an x, and we get x minus 3. And so this one will be 0, and this one will be 3. So those are our boundary points or critical values. And then we pick test points. So we can try like a -1, a +1, and a 4. And these are our pieces to try. Right, and we're just getting the signs. So if we plug in -1 into x, that's negative. And -1 into x minus 3 gives us x minus 4. 2 negatives multiplied gives us a positive. If we plug in 1, 1 into x is positive. 1 into x minus 3, so 1 minus 3 is a -2. It's negative. Right? A positive times a negative is a negative. Right? And then we'll put 4. 4 into x will be positive. 4 minus 3 is 1 is positive, and multiplying two positives gives us a positive. We want it to be positive, So we want these two sections with parentheses. So interval notation will be negative infinity to 0, union 3 to infinity. And this time you will have two vertical asymptotes. You will have x equals 0 and x equals 3 for our graph. So you could put either one of them in either box and you would be okay. All right, that one is similar. So I'm going to backtrack now to the first question in this one. And this is a matching thing, so I'll have to roll my screen a little bit. Okay, but let's look down here at the pieces we're looking at. And I started my graph on this earlier just to help because I was afraid I would run out of time. And I actually have plenty of time. But that's okay. That way we won't have to regraph this part. So, a log with a base other than 10 or e, and most of the graphing calculators, you can't put that in. You actually can put it if you have the TI-84, some version of that. I don't have one of those to be able to demo for you. So I'm going to show you how I do it without that. And I think if you're using Desmos, you would also need to go the way I'm going to show you. So instead of trying to graph the log-based something, I'm going to graph the exponential and then remember about inverse functions because the log is the inverse of the exponential function. So exponential functions are easy to graph, and we had those last time. So all of these are log base 3. Your parent function in this first problem is going to be log base 3 of x, right? And these are just transformations to it. So we're going to get the parent function and then do the transformations. So what I graphed instead first is 3 to the x because that's the inverse and that is easy to graph. Right? I just did 3 to the x and I picked 0, 1, 2 and negative 1, negative 2. Here's our graph. Okay? Now, remember with inverse functions, the x's and y's just switch. So I have my table. Now I can make my table for my log graph is 1, 0, 3, 1, 9, 2, 1/3, negative 1, and 1/9, negative 2. This is the graph I'm going to care about, but getting this table really was what helped me. Okay, so I'm going to get this graph for us. I think I'll put it on the same grid because remember they're going to flip across that line y equals x. And so I'll do 1, 0, 3, 1, 9, 2, 1/3 and negative 1. I can't hold that on there, Mom. And 1/9 and negative 2. So it gets closer and closer to your y-axis. And there is your graph of your log function. So I just graphed it by graphing 3 to the x and switching the x's and y's to get my table for this one. Here is your line y equals x through the origin. Notice it does flip across. And your domain and your range reverse, right? Whatever was domain for this one becomes range for the other one. and range for this one becomes domain for this other one, for the inverse. All right, so this red graph is my parent function working with multiple choice, and this is D. So D, so I don't forget, all right, is the one that looks like this. So I'm going to scroll through and pick it out. Let's see. That one looks like it's moved up a little bit. This one right here. Okay. And I'll use the mouse instead of my stylus. All right, so this one looks right. You have 1, 0 on there. You have 3, 1. This is the right one. So this was D. Right, and now we'll look in the list and see what these other transformations are going to do to it. All right, so A is +2 in with the X. That is going to move it 2 units to the left. So A, we're going to move this picture 2 units to the left, or if you're looking at your table, subtract 2 from your X's. All right, so we're going to scoot it 2 units to the left, but it's still going to look like this form, so it's not this last one. Not that one, it's upside down. We already used that one. All right, this one right here looks to me like it's 2 units to the left. You can check it with a point. Your point was 1, 0. There, it's gone 2 units to the left. So this we said is A. All right, then we'll go back down to our list. All right, I have a negative out in front. This is a vertical movement. We'll flip it upside down. So it's flipping over the x-axis. So this piece over here is going to point up, but it's going to turn this way. Okay, sorry, I should use the mouse. It's going to turn out this way when it flips. All right, and that will be B. Okay, not that one. That one, no. Maybe. It's flipped and it's going to get this piece of the graph right here is going to go down below. It's going to come down here. And this part's going to go up. I think this one may be it. Right? We can keep scrolling. That is not it. That is not it. So yes, this one is it, and Mrs. H has forgotten which one it was. Okay, it is B. So it has flipped upside down over the x-axis. All right, C. This time your negative is in with the x. That is also a reflection, but it is going to reflect across your line. The y-axis, the x equals 0, it's going to flip across that because it is a horizontal movement. So your graph is still going to, it's going to flip, it's going to be down here, but it's going to point the other direction. All right, so this one right here actually looks good. All right, it's going to flip straight across. We've still got this piece. And that would be C. All right, we already did D. That's the parent function. All right, E is going to just move the parent function up 2. So let's look up through here. All right, and it will be this one. It's still going to look the same, but it's moved up 2. And this is E. Right, F is all that's left, and it had a negative in front of both. So it flips across and it flips up and down. All right, you have a negative out here and a negative inside. So it is flipping up or upside down and over. And there was only one left. It's going to be the second one. And we'll check those. Okay. So that is how I would approach one of those graphs. If you listen to the video, Mrs. Allen does it differently. And there is nothing at all wrong with her approach. To me, that's just harder. I think it's easier to work with the exponential and then the property of inverses. She uses something we will learn, which is change a base. I believe it's in the next section. But you're welcome to watch those if you want to try it a different way. Right. You guys have any questions? All right. I'm going to stop there. The other questions in this section are just some graphs. You'll basically work the same way we did. Graph the exponential and then flip your x and y's to get the graph of the other one. Pick your parent function out and then do your transformations to it. All right, so we'll stop there. You guys have a great day.